In this video, I'm going to talk about how to get the global minimum variance portfolio in R using the PortfolioAnalytics package. I'm going to go through a simple example using some built-in data, which will give you an idea about how this is done. So the PortfolioAnalytics package is one of many portfolio optimization packages that are available. Another common alternative is Palmer, but I'm just going to stick to PortfolioAnalytics for the moment. Now, the global minimum variance portfolio is the portfolio that gives you the minimum variance of all possible sets here. Now, when you can't borrow or lend at the risk-free rate, it would be on the efficient frontier. However, once you start relaxing that and you can say invest on leverage, then it ceases to be on the efficient frontier. However, I'm just going to look at the global minimum variance portfolio for the moment. So what we need to do is we need to bring in our packages. And then once we've brought in the packages, we can go through the steps that you need to use in order for you to be able to get this global minimum variance portfolio. So what I might first do is I'm just going to remove everything from my environment. And the reason I'm going to do this is effectively so that I can avoid having stuff cluttering up my environment that is just going to cause potential errors down the track. So I have that firstly. Now what I'm next going to do is I'm going to bring in my packages. So for example, I need to bring in the PortfolioAnalytics package. And that's relatively unsurprising because if you're going to use the package, then you need to import it in. Now I'm doing this in RStudio, but you can use whichever GUI you prefer. If you don't have it already installed, then in RStudio, you need to go up to Tools and then Install Packages, and then you're able to search for the package. I already have it installed, so I don't need to do this. But if you don't, then you need to go to the install area. Then the next thing I need to do is I need to bring in other essential packages. So for example, I need to bring in XTS. XTS is effectively a time series package, so they can get everything in a time series, which is useful for me, or it will be useful depending on the format of your data. So it's not necessarily useful or necessary in all data sets that are automatically imported for you. But if you're bringing in data yourself, you might need to reformat it as a time series. So XTS is a useful thing for all of this. I'm not going to emphasize it in this video. The next thing I need to do is I need to bring in an optimizer. So I'm going to bring in the ROI optimizer. The reason that's necessary is PortfolioAnalytics, the basic steps that are involved here, is we bring in the data, then we construct a portfolio item. This portfolio item then has constraints added to it, then you add an objective function, and then you optimize it. The optimizing requires an optimizer. ROI is one of those optimizers that we need to bring in. So I've brought in ROI here. Now, the next step that I'm going to do is I'm going to bring in data. Now, PortfolioAnalytics has some prepackaged data that is going to be useful for us. And I'm going to use that rather than messing around with other miscellaneous data sources. By bringing in that prepackaged data, it means you can play around with it yourself. So what I'll go with data and then edHec. And now edHec is just the data name here. edHec is a university, but of course, it's just the data name. So let's run our code here, and then I'll show you what the data ultimately looks like. So I've brought it in to begin with. Now what I'll do is I'll go View in the console down the bottom, and I'll go View edHec. Now what this will do is we'll just bring up the whole edHec database here. What you can see here is there's a whole lot of things in this database. Now this is not the full database because there's also additional entries here in relation to particular assets that are going to be particularly useful for us. However, if we have a look over here, what you can see here is there's a few different assets here. So the few different assets here are going to be ones that we're going to focus on. And these are effectively different funds. These funds have different returns over time. So in the row name here, we have a date, and then we have different funds with different returns associated with it. So I'm going to use these funds here as my assets that I'm going to optimize over. So I've brought in the data. Now what we need to do next is we need to select the data that we actually want. So what I'll do here is I'll just call this portfolio R. Now you can call it whatever you want. I'm calling it R because it has the returns in it. Because as I mentioned before, this data has returns. So it's going to go edHec, and then I need to select the columns that I want. So I want all rows, and I want columns 1 to 4, for example. You could go 1 to 6, you could go all of the columns. It doesn't really matter. I'm just using a subset so that I can illustrate it. Now, what I next need to do is need to create the column names. So for example, what I can do is I can create column names here for R. So R is my new return data set. And now what I'm just going to call it, I'm going to give it some abbreviations. So for example, I'll call one CA, then the next one I'll go CTAG. It doesn't really matter what you call them. You could call them ABCD. So it doesn't really matter. So just call it whatever you want. So CTAG, and then the next one, let's call that DS. And then the next one we'll do is we'll call that EM, standing for emerging markets. So that's effectively what my assets are here. So I'll just run that, and let's have a look at what R looks like now. Now, what you'll notice here is I created an error because I forgot to use a comma. Oh, no, I forgot to use a C. So always remember, make sure that you have the correct syntax. And again, I have another error here because I obviously forgot to include something. I capitalized C. So let's try this again. So oftentimes you'll just make silly errors like that. It's just important to know where these errors are coming from. Then we go view and then R. So if we view our return matrix here, what you'll see is we have 4 returns over a whole time series here. So let's go back to our code. So the next thing I need to do is I need to tell R what my funds are. So I need to tell R what the name of my things is. So I'm going to go funds, and that's going to equal the call names here of the R matrix. Now, the reason I need to do this is I need to be able to tell PortfolioAnalytics what the name of my assets are. So this funds vector, that effectively contains the name of all of my assets. So it's important you do this so we can feed it in to the portfolio aspect. So that's my first preliminary step. So let's just go to begin with. I'll call this step 1, and then I'll call this data. Now, step 2 is to initialize the portfolio object. Now, when you're initializing the portfolio object, there's nothing magical about that. We create this portfolio object, then we add constraints and add an objective. So here, my portfolio object, let's just call this, it doesn't really matter what you call it. I'll call this port min var. So I'll just go with port MV, just for short. So I've initialized it. Now that's the initial portion I need to say. But then what I need to do is I need to add things to it. So I create this, and then what I need to do is I need to tell it, well, what assets are going to be in my portfolio. So I'll create this and then create portfolio spec. And then after I've created the portfolio spec, I need to tell it what my assets are. So I'll go assets is equal to funds. Now the reason it's equal to funds is you remember this funds vector contains the name of my assets. So I'm basically just telling R that my funds are in this portfolio assets vector. Now that's the first thing I do to initialize the portfolio object. Now the next thing that I want to do is I want to start adding some constraints. So that is important because if you don't add constraints, then it's difficult to optimize when there are just no constraints. It's unconstrained optimization. It ends up just being totally meaningless, really. So I'll go with step 3, add constraints. Now, when you're adding the constraints here, it's important to bear in mind that some of these are almost quasi-necessary. Now, the first one that I'm going to do here is I'm going to add a constraint which tells us we need to be fully invested. So in order to do this, I go port MV. Now recall, port MV is my portfolio object that I then am adding things to. So what I do is I go port MV and I go add constraint. Now, I next need to tell R what is going into my constraint. So I'm going to tell it that my portfolio is exactly what it was called. So portfolio is equal to port MV. And then what I'll next do is I'll go type, which it tells R what the type of constraint is. And I'll go full investment, which is effectively shorthand for saying we need to invest all of our money. So all of our weights need to sum up to 1. That's effectively what it's shorthand for. So that's my first constraint. Now what you can next do is you can add what's called a box constraint, which is also called a position size constraint. The box constraint is necessary here so that we know kind of what needs to go into each asset. So what I'm going to do is I'm going to constrain the weighting in each asset to being between 0 and 0.99. That tautologically means we need at least 2 assets in our ultimate portfolio, One of those assets could be 99% of the portfolio, but I just want to make sure there are at least two. So I go again, port MV, and then I go add constraint. And then again, I'll call my portfolio object. And then what I'll next do is I'll go type is equal to box. The way to think about this is you're effectively creating a box into which your asset weight needs to fit. So I'll go type is equal to box, and then need to specify a minimum and a maximum. The minimum is the minimum weight in those assets. The maximum is the maximum weight in each asset. So I'll go min, and I'll go equals 0, which just means we need to be at least 0 weight, i.e. no negative weights, i.e. we're not shorting effectively. And then max, I'll go with equals to 0.99, which is effectively 99% of our portfolio. So we have two constraints there. You can add other types of constraints. So for example, you can add factor exposure constraints, but we don't at this point have additional factors that I'm going to be able to add exposure constraints for. You can add other types of constraints as well, such as portfolio concentration constraints. I'm not going to emphasize these at the moment because we're just looking at the global minimum variance portfolio. The next thing I need to do is I need to add the objective function. So let's start with step 4 then. So I'll go down to step 4. So I need to add the objective function. So the objective could, for example, be maximizing returns, or it could be minimizing risk, or it could be theoretically maximizing the Sharpe ratio, albeit that's a little bit more complicated. And in many data sets, it's going to fall over when you're using ROI. So as your optimizer. So again, we're just focusing on the global minimum variance portfolio. So in order to do this, I go port MV. Then what I do is I go add objective. And then what I do again is portfolio is equal to port MV. And then what I need to do is I need to tell it what the type of the objective is. So the type here is effectively a risk type. So I go type is equal to risk. And then I need to tell it what type of risk we're effectively optimizing over. So we'll go name is equal to var. Now, the minimum variance portfolio is the one that minimizes the variance. You could theoretically specify standard deviation here because standard deviation is the square root of variance, but oftentimes that ends up messing up. And the reason for that is in a optimization process, when you're doing a closed form solution for this, you need to engage in differentiation. The differentiation is much neater when you're looking at the variance than when you're looking at the standard deviation. So hence why we've got variance here. Again, for practical purposes, it probably won't matter that much, but it's generally going to result in more tractable solutions if you specify variance here. So far we've added the objectives. Now what we need to do is we need to engage in optimization. So that will be our 5th step here. So we go step 5 and then optimize. And this is where you might recall that I had imported the ROI package before. So in order to optimize, I need to create effectively an output object here. So I'd go out, so output, doesn't really matter what you call it. Then I'll go, then I need to call the command optimize portfolio. Now, when I'm optimizing the portfolio here, I then open parentheses. Now, the first thing that I need to specify is the returns. Now, I need to specify what my return matrix or my return vector is. Here, I'd call it R. So I just go R is equal to R. The next thing I need to do is I need to specify the portfolio because we need to know what portfolio we're optimizing over. So I'll go portfolio is equal to port MV. Now, the next thing I need to do is I need to tell it what optimization method I'll use. So I need to go optimize method. And then I need to go ROI. So I'll be using the ROI optimizer in order to optimize. And then finally, I need to go trace is equal to true. Nothing magical about that. You just enter that as a command here. Now, that's effectively what we have here. Now, what I'm first going to do is I'm going to run all of the steps up to step 4. This will help me to ensure there are no errors. And as you can see, this ran with no errors. Now, what I'm next going to do is in the console, I'll go show and then port MV. Now, when I do this, what you'll see in the console is you can see the enabled constraints and you can see the enabled objective functions. So here the variance objective function also tells me my asset names. So effectively, that's what we have here. So we have our various things that have been entered in. Now what we can do is we can run our optimization. So we then click run and we run the optimization. And this goes into output. So what then is in our output? So I'll go view, then output. And this will tell you what objects are in the output array. So we have up here a weights area, which is giving you the weights in each of your underlying assets, one of which in our case seems to have a 0 weight. You have the objective measures and various other things here. So the objective measures is going to be your standard deviation. So it's going to tell you the standard deviation of your portfolio. So in order to extract these, you're going to be able to extract each of these individual things here. So if we go to the go back to our code here, what you can also do is you can add in code to extract, for example, the weights. So you can go out weights, and then the way to go out weights and extract the weights is you need to get your output, which if you remember is our output from our portfolio. Then again, open up square brackets, and then what you just go with is go weights. And you can do the same thing for everything else. There are other shortcuts to extract the weights, but I'm just going to go with that one. So we've got output and then weights, and then I've now got my weights. So let's have a look at what this looks like. So we now have these as a vector, and what you can see is we have the weights for the portfolio in this particular case. So that's effectively what we have here. Nothing particularly exciting or unusual about it. That's how you'd go about getting your global minimum variance portfolio in R. Now, I hope this has given you a bit of an idea about how to do the optimization here and given you an idea about the steps and the overall syntax to use the PortfolioAnalytics package in R. In any case, I very much hope the video has been useful to you and somewhat interesting, and I wish you all the best with your future R programming. And in any case, thanks so much for tuning in, and I hope to see you for future videos. Bye.